Welcome everyone to iOSoho. My name is Dalton Claybrook. I'm a developer here at Peloton. I'm excited to talk to you today about scripting in Swift. So a little brief background about me. Katie already mentioned I work on a team called the Apple platform team, iOS platform team here at Peloton, subset of the iOS team. And one of the things that I do day to day is maintain a tool that we call Argon CLI, and that is a command line application written in Swift. So a little bit of background, that tool has certainly influenced this talk. But let's get into the agenda, talk a bit about what we'll be talking about today. So I'm going to talk about what we mean when we say scripting in Swift, what I'm referring to when I say that, because there are multiple interpretations of that. We'll get started with a brand new CLI application. We'll talk about how to make that application a little more ergonomic, make it feel a bit more scripty if you're familiar with scripting type tasks. There's a demo. We're going to talk about the ergonomics of calling the script, invoking the script, and making sure that your users, your clients are always using the latest code as if they would if this were an actual bash script or something like that. And then we have some trade-offs that we can talk about when choosing this path of scripting in Swift. So what are we talking about? So when I say scripting in Swift, what I'm referring to is doing tasks, things you might normally do in Bash or Python or Ruby, etc., but doing them in Swift instead. So why would you do that? You prefer Swift, you're more comfortable with Swift, you prefer the environment of Xcode, you have familiarity with the APIs that you would be using while writing this code, so it's potentially could be a good choice for you. And then I alluded to this a second ago, but actually using, invoking, calling the code as if it's a script. And that involves things like making sure that you're always running the latest code that's available on your machine, making sure that you're potentially obscuring compiler output, build system output, dependency resolution, things like that, that your users, your clients, perhaps other developers on your team, they don't necessarily care about those kinds of details. They really are more concerned with the output of the Swift program, things like that. This might come as a surprise, but what we won't be talking about really is Swift REPL. And if you Google scripting in Swift, likely the top 3 or 4 results you're going to see are related to the Swift REPL, and which is why I kind of make that disclaimer. But we're not really going to be talking about that in this talk, but I do encourage you to take a look at that. So if you're already feeling a bit deceived by the talk title, not actually being real by the book scripts, then let me further manage your expectations with an alternate title. We're actually going to be talking about writing command line apps that feel like scripts in Swift. Okay. Let's get started with a brand new application that we're going to call AppSafe. This is a tool used to validate App Store builds. So you can imagine the types of things you might want to do to validate an App Store build before you submit it to Apple. And here's the vision. Here's kind of what that might look like. So we are invoking our command line tool. We're calling a subcommand called audit. Audit is a subcommand. This is sort of for future-proofing it, right? Because you could imagine that you would want to add additional subcommands. Imagine you want to say fix a binary. Like if you identify issues, maybe you want to later fix that binary. So that might be a different subcommand. And we have some additional command line arguments here. We're passing a path keyword, and then we're also passing the file path itself to the IPA that we're trying to audit. So this is the vision. Here's how we might get started. You're welcome to follow along, but certainly not necessary. But this is kind of how you might get started along building this application. This might be familiar to some of you, but we're going to be using Swift Package Manager. So we want to make a directory, change into that directory. We'll call Swift Package init. This is something you might also be familiar with, but we're going to be passing this argument type equals executable. This is not the default type. If you were to just run this without this argument, it would build a library. I think that's a more typical use case of Swift Package Manager is to build libraries. And then we're going to open a package.swift file. So this should be, if you've never just opened a package Swift file directly in Xcode, you might be surprised actually at the level of support you get opening a package directly in Xcode. It really feels like a full Xcode project when you open a package. So definitely check that out. So we'll start off with some code that looks like this once we remove some boilerplate. And before we can implement the behavior of our tool, we need to do some common scripting tasks. We need to be able to answer these questions. If we want a tool that can compete with other scripting languages, we need to be able to do some very basic behavior, potentially even more than is enumerated in this list. But we're going to talk about some native ways, some very like pure Swift, pure Mac OS frameworks to do these types of things, and then we'll elaborate later. We'll expand later on how to improve the ergonomics of this type of work. So let's start off by talking about parsing command line arguments. So we get access to this namespace command line, and we can ask it for its list of arguments, an array of arguments, and we're asking for index number 1. This might be surprising if you're not super familiar with command line apps, but argument 0 is always going to be the path of the binary that we're invoking. So argument 1 is going to be the first argument in the list of arguments that we pass to the tool. And we also want to make sure that we have an exhaustive check here, just in case you pass something that is not expected by the tool. So we can exit early, give some helpful diagnostics, and then call our handle audit function to actually do the work of auditing the binary. So a little bit of boilerplate. We're going to add even more boilerplate to this. We want to parse that path parameter, if you remember from the vision. So we're going to make sure that we're passing in enough arguments, enough command line arguments. We're going to check against this path keyword. We're going to make sure that we can get our path out of this list of arguments. Otherwise, we're going to exit early. And again, quite a bit more boilerplate here. Hopefully, we can clean that up in a bit. So building on top of that, we want to be able to work with the file system. That's a very common thing that we might choose to do in a scripting language or another kind of command line application. So here's how you might use File Manager to do some of those types of tasks. You might already be familiar with File Manager. It's a pretty old API available in the Foundation frameworks, available in Objective-C. In fact, you probably have spotted a very interesting type name here, Objective-C bool. That we have to use in order to pass by reference to see if we're talking about a directory or a file or some other kind of file. So there's quite a bit of boilerplate here, but ultimately we make sure that our file exists. We make sure that it's not a directory, and then we can read the contents of that file, print them out, and actually use them in our tool, right? And the last bit of boilerplate, the last bit of work, the question that we would have to answer to build an appropriate, working functional script in Swift is, how do we invoke subprocesses? How do we spawn subprocesses? So this is, of course, the most verbose and the most boilerplate of all. If you might be familiar with process, aka ns task, if you're come from Objective-C. And there's lots of stuff that we have to do to set this up. We have to set an executable URL. We have to pass our list of arguments. You can see here we're just using the file system utility as our example. So you got to provide that. We have to set up this pipe object, this very interesting and weird looking pipe object that we can read from after we've spawned the sub process. We have to wait for the process to finish, decode the output of that pipe into a string, and finally we can actually use the output of that process. So of course, most boilerplate of all in this slide. Okay, checking in. We have solved these three problems that we wanted to solve. We created a executable package. We parsed the command line arguments. We accessed the file system. We spawned the sub process, some of the 3 basic building blocks of building a script. But you have to admit that it is quite verbose, quite a lot of boilerplate. You could understand why this wouldn't be really a feasible approach when building a simple script. And it's not very ergonomic. So we'll talk about improving the ergonomics of this kind of work with Swift packages. So some of you may have been waiting patiently for this slide to show up, but this is a package that Apple publishes called Swift Argument Parser. Very, very awesome package. In fact, if you take anything away from this talk and you haven't heard of this, then just know that this package is awesome and you should definitely take a look at it. But it simplifies the process of building a CLI. It provides support for native commands and subcommands. It gives you really sort of first-class support for various kinds of arguments that you would want to pass into a command line application. So they call them arguments, options, flags. built-in help docs. This is something that we didn't even see in the previous slides, but you know, your users may want to invoke this tool and ask for documentation about how it works. And then some bash completions, if you're familiar with those. You get some built-in helpers there, which is cool. So what would this look like if we were to transform it to use Swift Argument Parser? This was the example that we saw earlier, parsing command line operations in a very imperative way. And this becomes quite a bit simpler. This is very declarative. This should feel nice, especially if you have been using Swift UI and you've been using declarative APIs. This should feel sort of like a breath of fresh air to you. And you can see that our commands are defined as their own types. So we have this root level type that is our app safe binary, and it has a subcommand. It doesn't really do anything of its own, but it declares a subcommand called audit, and that sort of tells the argument parser that it's able to route invocations of audit directly to this particular subcommand. So that's cool. We also have a command line option. We're using a property wrapper. Again, this should feel very declarative, very friendly, Swift UI-esque, and we get some helper APIs along the way as well. You spotted the different ways that we could specify our path and some helpful documentation here. So yeah, simplified this quite a bit, and you're also getting some safety with this as well. You're getting you can see that the path argument is non-optional. It's a non-optional string. So argument parser is going to handle the case of you're not passing in a path. It knows that this audit subcommand expects a path, and so if you don't provide that, then your run function will never actually be invoked, and the users will get an interesting help message from that. Here's another interesting package called PathKit. It really simplifies the process of working with paths. So let's see what that transformation looks like from File Manager over to PathKit. So very, very basic. We instantiate a path using its string representation, and then we can just ask it things like, do you exist? Are you a file? And then we could even read the contents of that file directly using PathKit. And there's overloads for string, overloads for data. So whatever kind of way you want to read the contents of that file, you can do so with PathKit. And we can actually, with a small amount of extra work, we can make path conform to expressible by argument, which is a argument parser type, and simplify this ever so slightly more. We can actually say that our audit subcommand wants a path. And if it's not able to be decoded from the command line input, then it won't be available to us inside of this command. And our final bit of boilerplate that we wanted to optimize is process. So I have a couple additional thoughts on this. Process is a very powerful API, is also known as NSTask and Objective-C-LAN. You can do all sorts of things. You can suspend a process, resume a process, wait on the result of that process. You can read its termination status. You can provide it with a custom set of environment variables. You can really go crazy with pipes. You can chain them together. You can spawn multiple and route their output from one to the other. So quite a bit, very powerful API. But if you're willing to trade that power for ergonomics, then there is at least one, actually possibly many packages that would handle this simplification for you. Or you know, of course, you could write your own helpers. We've done something similar on our team at Peloton, but there's a package called Shellout that really helps simplify this at the expense of sort of the power of this API. So the most verbose bit of code we saw from earlier now sort of collapses down into this single line. So you can see we're still calling file, we're still passing the same number of arguments, but we're getting all of those other affordances for free, and it's automatically decoding the result of that output to a string for us. Anything else would have thrown an error from this shellout function. So greatly simplifies. This should feel like something like Bash or Ruby, where you can invoke a subprocess with just a single line. So let's look at the full comparison. I'm surprised that you can actually maybe even make out this code. This screen is humongous, which is awesome. But and it collapses down to a considerably smaller bit of code. So this is clearly we're removing a ton of boilerplate here, and really what we're left with is just the behavior of our application, which isn't much, right? It's very simple, and that simplicity is reflected in this new bit of refactored code. So that's pretty cool. Okay, brief demo. I got to do the mirroring dance. 1 second. Okay. That didn't work. There we go. Okay. Okay, that's what I want. Perfect. Okay, so here is our app safe app that we were working on. It's a little more kind of fleshed out version of that app that we were looking at a second ago. So again, here's our root command, which doesn't have any functionality of its own, but it does provide some documentation, a version number. And we have our single subcommand audit. So let's jump into audit and see what that gives us. So some options here, we can pass in a URL or we can pass in a file path, and the app knows to either download the file from a remote server or load it from disk. And so that logic is happening in the run function. And you can see we have a downloader API. This is something that I put together, but something I haven't talked about, and I will just mention very briefly, is if you've used Swift concurrency, if you've used async await, those tools have really, they really shine. They've really unlocked an incredible capability for CLI applications, because previously there's this dance that you have to do with a CLI application, which is inherently, a very synchronous task in getting that to work in a world that Swift provides, which expects the ability to use asynchronous operations, especially like network requests and things like that. But through the use of async await, structured concurrency, we have access to these capabilities from within a command line application as well. So, and we even get some affordances from argument parser. You can see this is an async parsable command, not just a parsable command, and that gives us the function, the run function, which is an async function now, which is very, very cool. I thought that was awesome. But very simple implementation of download. You can see that we're just accessing URL session, checking the status code here, doing some decoding, that sort of thing. And very powerful that we can do that right inside of a command line application. And then we have our list of audit tasks here. So this is a very plug and play. We can make new audit tasks. We've got some sort of boilerplate code down here that's actually performing those audits. And you might have also spotted we've got a more structured concurrency APIs down here that enable us to kind of perform tasks in parallel, which is interesting. But we're not going to talk much about that. I do want to talk about our specific audit tasks and how we might be able to extend that. So we've added a few tasks. We have our static framework tasks. Make sure that there are no static frameworks embedded in our App Store binary. We have a get task allow task, very interesting name, but make sure that our entitlements inside of our App Store build contain a get task allow entitlement that is set to false, because that is not allowed to be set to true in App Store builds. Otherwise, people could debug your App Store builds, right? So, but what we're going to be doing in this demo is implementing a strip task. So you can see the description of the strip task here. We want to ensure that symbols have been stripped from our binary, so we can thin up our binary and not have this bloated application that's installed on our users' machines. And this is even more pertinent since Xcode 14 dropped support for bitcode. So let's see what that would look like. First and foremost, we're going to get a path to the actual binary itself. So the path that we got is a path to our .app file, which has already been unarchived from our IPA. And so we want to get the binary inside of it. And we're using some helper APIs from PathKit to do this, to get the last component without its extension, a very handy helper function here. The next thing we want to do is get a temporary file path. So I got a little helper method here for getting our temporary directory. We're going to create a new file path of a file inside of that temporary directory, which will be the stripped version of our binary. And we're also going to do a bit of housekeeping here. If we had run the tool before and we want to run it a second time, we'll make sure to clean up any files that were left behind previously. The third thing we're going to do is actually invoke the strip API. So here we are invoking a subprocess, spawning a subprocess, and this is a tool called strip. It's available. It's installed already on your Mac in your Mac machine. I'm not sure if it might be provided by Xcode and just sort of symlinked into your path, but so we will be invoking the strip utility. We're passing it our original binary path, and we're passing it this output path where we want the result of this call to be stored. And last but not least, we are going to actually do the check that we want to do, right? So we have another helper utility here to take a hash of our original file, take a hash of our new file, and then compare those hashes. If we invoke strip on a binary that has already been stripped, then no changes occur. The output file will be identical, and therefore the hashes will match. So if they don't match, that means that the binary has not been sufficiently stripped of symbols given the list of options that we provided to the strip utility. So that would be an error in our auditing tool. So now that we've done that, let's actually run it. Okay, so I'm going to run it with Swift run. The name of our app, the subcommand. This is where we get into actually passing arguments, and then pass it a path to the argon.app. Argon is the name of our internal sort of code name for our application, by the way. And here we have run our 3 checks, and they are all passing, so we can safely submit our app to the App Store. So. Oh. Got to do this dance of mirroring, not mirroring. Okay. All right, a couple more slides. Earlier I talked about using Swift, using this command line application as if it were a script, and we haven't really talked much about that. So I'd like to get into that. Of course, you could invoke it the same way that you just saw me invoke it. We could use Swift run, give it the name of our application, pass a list of arguments, and that would work fine, except there's a couple downsides to this. The first downside is that you have to run it from inside of that package directory, or you have to pass an additional argument to the invocation to give it the package path. And so that's not really ergonomic for the users of your command line application. The other downside is that doesn't do anything to address the clutter of terminal output. So imagine that you're on the first invocation of this. It's going to be resolving your package dependencies. It's going to be building the app, possibly spitting out warnings from your dependencies if your dependencies haven't been good stewards of their warnings, right? So that's just not ideal. Another option, this is something that we actually tried at Peloton and we were doing for a little bit of time, was have a private homebrew formula. So we have a private homebrew tap. We expect our developers to regularly update this homebrew package. But of course, there's downsides to that as well. That's not always running the latest code that you want your people to be running. If we have like a critical bug fix within this tool that we want to deploy out to everyone right away, then there's some process that we have to involve to do that. We have to rebuild our homebrew formula, and then we have to expect that all of our developers are going to update the tool, and a lot of the time that's not very practical. So what we end up doing instead is having a small wrapper script, and this sort of bridges that gap. It enables us to do things like always run the latest code and obscure build output, and also be able to run the script from at any place on your machine. So very quickly, I want to show you what that looks like. I know that we're running a little long here, but let's take a look at it. Okay. Oh, whoops. Optimize. Okay. Cool. All right. Something that I haven't shown, but that is also available in this Swift package is a Swift package plugin. So we're not talking about Swift package plugins today, but this plugin, what it does is it generates that wrapper script for you. So I'm going to just run the Swift package plugin, and the name of the plugin is script. It's going to ask me for appropriate permissions. And now it has generated the script that I was just the wrapper script that I was just talking about. So let's take a look at what it looks like. And here it is. Here's that wrapper script. It's very simple. It's setting up some basic variables that are used. It outputs this text to let people know that what's going on. So they're not just sitting there waiting for something to happen if the build happens to take some time. But instead of outputting the build output, we're going to redirect that output to a log file. And then only in the event where our exit code of the build is non-zero do we output that build output to the console so people can debug the problem if there is a problem and exit early. And finally, here's where we do the work of invoking our script and passing any trailing arguments that were provided to the script. And the package plugin also gives a bit of a helpful information here for copying it into a place that is accessible in your path, right? So with these changes, I can just run appsafe audit path. You see the building output, and it's very uncluttered. It's very sort of ergonomic. It feels like a script, but the benefit is it's always running the latest code that's available in your main branch. Okay. Two more slides. Okay, trade-offs. So of course, it takes an application. It's going to Swift application in particular takes time to compile, but hopefully you can benefit from incremental compilation. And if your people are running the script quite frequently, like our people are, then you would hope that they wouldn't have to deal with long build times that frequently with incremental compilation. A little more boilerplate, but you can see that you could see from earlier slides that we were able to reduce the boilerplate considerably. And the boilerplate that we're left with is a boilerplate that you might be comfortable with. As a Swift developer, we expect a little bit of ceremony when we write applications. And so I think it's acceptable to accept that kind of ceremony when writing these basic scripts as well. And also, getting back to that same point, few first-party conveniences. We saw the heavy boilerplate use of process. Apple hasn't really invested in that kind of a convenience for us at this point, but I think it's an acceptable trade-off in certain circumstances to be able to leverage Swift packages or our own built-in conveniences if we want to be able to create those conveniences for ourselves. So with that in mind, I hope you'll give Swift scripting a try. I have some resources here. That tool we were just working in is an open source tool, so that's the top link in this list, and feel free to ask me afterwards if you're looking for another link for it. But thank you very much for listening to my talk. We do have a microphone for questions over here if anybody has any questions that they'd like to ask.
Actually, there we go, test.
Hey, so great talk, really interesting. In the parsable command, there was an @ option. What was that? Was that part of the protocol for parsable command, or is that?
Yeah, that's a feature built into Swift argument parser, and they expose a few. That's a property wrapper, and they expose a few property wrappers for different kinds of arguments that you would want to pass in. So that's that one was an option, and so that's what they call things that have the -- path followed by a value. But they also have ones for just a flag, and that would be -- path with no trailing value. And then they have a third, which they just call argument, and that would be if you just passed basically a string with no flag field or whatever. So those are their 3 built-in conveniences provided by argument parser. Argument, a bit of an overloaded term there. But.
So we have time for one more question. Anyone else have a question? All right.
Way in the back. Hey, Danny.
I'm hustling. I'm hustling.
Hey, Dalton. Wonderful talk.
Thank you.
Curious, is there any way to output or build this thing as a executable or a binary that basically you can give to people so they don't have to know anything about Swift or don't have to know that Swift's even involved?
Yeah, if you wanted to distribute this to end users as I mean, I think Homebrew would be a great choice in that case. And there's lots of examples of apps that are doing this already, like SwiftLint, for example, is a very popular command line application that is written 100% in Swift. And they have if you look at their repo, they have a make file, and the make file kind of goes in depth around what optimizations they pass to Swift in order to compile it. Yeah, Homebrew would be a good option. There's other package managers like Mint. We use Mint for a couple things within our code base. So that's just like sort of a third-party binary Swift-centric tool for installing binaries without bringing along the source code. So yeah.
Thank you.
You're welcome. Okay, thank you so much.
Thank you.
Hello. We're doing it. We're back in person, seeing each other's faces. Some of you I haven't seen in so long, and like I didn't have a chance yet to talk to you, but I'm really excited to catch up a little bit. I'm kind of echoing. Let's see. Hello. Okay, this is better. All right. So, and I'm short, so I guess I need to be next to the computer. So I'm really excited to be here today to talk about a topic that is both like abstract and very exciting, which is modularization. And this is something that I've spent a bunch of time doing at Twitter and elsewhere. So I'm excited to share my experience. Am I echoing? Okay, I'm just echoing for myself. All right, great. So this is what to expect from the talk. I wanted to create a talk that is interesting for a broad group of people. So like people who maybe aren't exposed to this topic, and then people who have done a lot of this kind of work before. And then if you have any questions about sort of examples I talked about, or you want to get deeper into anything, let me know. But yeah, we're going to start with an introduction to modularization. Then I'm going to talk about, different companies I've worked for and how modularization helped us succeed in different things we were doing. I'm going to break you up into groups to do an exercise because I know basically you're all here to talk to each other. I mean, speakers are cool. It's an excuse to meet up. And then I have a bunch of tips based on my experience about how to approach these kinds of projects. All right, so I'll start with my experience. I've worked at a bunch of interesting companies over the past few years. Most recently, I was at Twitter, and more about that later. Actually, there's at least 2 former Twitter engineers in the room. So you can find them, see if you can find them later. Before that, and at Twitter, I worked on Twitter Spaces, which is Twitter's live audio layer. I also worked on in-app purchase and creator monetization. And before that, I was at Glossier. At Glossier, I built a brand new social commerce app. So like combination of, product reviews and community. And I also did some like React development there. I was a founding engineer at a tiny startup called River. I worked at Tumblr and did, a bunch of interesting projects there with wonderful people. And then I started my career at the New York Times. I said that. I really love to work on greenfield projects, either at really, small companies or maybe even mature companies building new products for an existing audience. And I like to give talks. This is me in Japan talking about blockchain. I ended up not buying anything. And then that seemed like a bad decision. And then maybe it was a good decision. I like to give talks at meetups, especially like globally, to get to know different communities of iOS developers all over the world. Okay, so the next slide is my favorite slide. So I wanted to start by just defining this term. What is modularization? So who here has been to Chipotle? Okay, so at Chipotle, you get to decide what's in your burrito, right? And everything you can put in your burrito has a different container. Maybe you want beans, maybe you want chicken, maybe you don't like spicy things, you're allergic to onions and stuff. So modularization is basically building a code base that functions like the kitchen at Chipotle. You can build something that's based on beans. You can build something that's chicken and beef. Maybe it's vegan. So this kind of architecture allows you to basically write a iOS code base where rather than having all the code in one target, code exists across different targets and modules and is better for, building all kinds of different products. Yeah. Beans, maybe you don't like beans, maybe beans are a must. Yeah, we've all been there. So I thought to kind of further talk about this topic of modularization, I would talk about some of the projects that I've worked on and how modularization allowed us to succeed. So the first thing I did when I joined Twitter was build an in-app purchase framework. So on iOS, we didn't have an in-app purchase framework before. We wanted to build something to then build creator monetization features. Like our ultimate goal was a product goal to allow users to be able to motivate users to create more and better content and connect in different ways. But we did it by building sort of a in-app purchase framework and then sort of a separate framework for the UI. And then the initial feature that I worked on was like scrapped. I'm sure you've all worked on things that maybe at some point product is like, I don't know about this feature. But then Twitter Blue, which is infamously blue check marks for everyone who pays, is based on Twitter Blue, which was a feature on top of this payments framework. So that's just an example of a feature where, you know, breaking the core functionality out into a separate part of the code base lets you build more things and iterate faster. Another project that I worked on was Twitter Spaces. So after I worked on in-app purchase, I moved to Spaces, which was really cool. I don't know if you guys have listened to Spaces before. I used to like join the Twitter Spaces official Spaces and talk about features that I launched, which was really cool. And basically on the Spaces team, one of the things that I did was modularize that feature. So it was actually a surprisingly very large, very complex feature. It was built on top of the old like Periscope code, which was like a live news feature, an app. And it was all part of this main Twitter code target, built very, very slowly in Objective-C and Swift. And imagine like, anytime you build a new feature, you have to build your code directly into the Twitter app and then tap all the screens until you get to whatever you're working on. So it was just very inefficient in many different ways. Running the tests was very, very slow as well. So, you know, I led a project that broke this feature up into lots of different modules, and I'll talk more about that later. And then another project that I worked on at Tumblr was launching an iMessage app when the iMessage app store came out a while back. And what was cool about this was that basically Tumblr wanted to build an iMessage app so that Apple would like us, you know. That's the thing you have to do. Like Apple's like, oh, we just created this new ecosystem and you have to just build something for it. But Tumblr had this modularized GIF maker. And so I thought that was really cool. So I ended up leading a project to build it into an iMessage app. So it was very flexible and something that could be taken into a completely different app and built as its own standalone experience. And we don't have to go over this, but maybe I'll share it later. It's just a bunch of definitions that have to do with modularization. All right, audience participation. So turn to someone next to you and maybe wave at them, acknowledge each other. And we're gonna take 5 minutes and do a modularization exercise. So I'm sure most of us, all of us have used Twitter. So that's the example, and that's where I was just working. But you know, we all, you know, hopefully know what the Twitter app does. You know, you can write a tweet, you can look at other people's tweets, you can send a message. There's all kinds of other functionalities, and then just like basic app stuff, sending logs, requesting data from the back end, you know, ads and stuff. So the exercise that we're gonna do is basically, I want you to pair up with either one or two people. And by the way, for the virtual people, you can just do this on your own. And you can leave comments in the chat if you want. And think about if all the code on the Twitter app was in one place and you had to break it up, how would you break it up and what would you do first? I think what would be most interesting to talk about is what's the framework around the decisions that you're making. Like, is it focused on improving future features? Is it focused on optimizing core parts of how an app functions, like a networking library? So we're going to take 5 minutes to do that. I'll be walking around seeing if you guys have any questions, and then we'll regather, and then I'll talk about how I did this at Twitter and share some advice. Does anyone have questions on what we're doing? The question was, is this pre-Elon or post-Elon? Pre. That actually relates to one of the things I'll share at the end around defining the end state of a project without knowing what the future is going to hold. So yeah, let's take 5 minutes and do that, and then I'll gather everyone. Set timer for 5 minutes. Hi. Sorry to interrupt.
Hello.
Do I sound weird?
It's perfect from here.
Okay,
It
for
must be
some
weird
reason
for you.
I can hear myself echoing, so I just wanted to make sure
from
that
here
it
it's
sounds
good.
okay. Okay, good. I'm just listening.
Oh yeah. So I did this at OkCupid, and so we started with authentication and
Yeah.
started importing our packages into a test app that we then used to shorten build time. And all that. It was fun.
Yeah.
Yeah, I love it.
Did you guys figure out your philosophy yet?
Well, I think you have to.
Yeah. Love it. Talking amongst yourselves.
Yeah, and then like every one of these can be like its own like analytic. Once you do analytics, that's it.
No, it's like everyone wants to talk to each other. I feel like it's the whole idea. I'm just eavesdropping. Yeah.
Try Swift.
Yeah.
Yep. But you don't necessarily.
Cool. We're gonna reconvene in like a minute. Talk about, if you guys want, you can share how you approach the problem. Or just shake your, it's very shake your head, for sure.
Hello. Hello. Is your mic on?
Yes. Okay, we're gonna gather it in a minute. And if you want, well, I'm actually out here. And if anyone wants to share how their group approached this problem, I think I want to take like 1 or 2 answers, or at least 2 or 3. Okay. Is there another mic? Is it a problem if I'm walking around for the remote people? Okay. Yeah, can you bring it to? All right, cool. So yeah, the question was, if you had to re-architect the Twitter app to modularize it, how would you start? The timer went off. How would you start, and what would be your sort of conceptual approach? Does anyone want to share what they thought of?
We need 1 volunteer, or we can't go on with this presentation. All right, I'll cheat. I'll start.
Okay, Jordan.
We would start with authentication in our group, because then once you can make network calls, you can start building out other features.
Cool. Thanks, Jordan. Anyone else?
Room full of developers, no one has ideas? There you go. Thank you. Thank you.
So aside from like, we thought about networking as well, and some of like those shared services that kind of get used throughout your app. But then another one that we thought of was kind of like your shared UI and style components, which is maybe not like every single like view, but maybe like the shared things that make up those views. So then you can use that wherever you're building things.
Yeah, I love that. And I think that is a good ingredient in a user experience that feels really cohesive, right? Anyone else want to share? Maybe one more.
Okay, I see a hand. This is Peloton, so we have to run everywhere.
Sure. So here's one non-obvious, but at the same time very obvious way of doing this. You modularize based on your organizational structure.
Say more.
So, okay, in any large organization, changing code, changing how code works, changing how features work across organizational boundaries has a cost. And the further you reach, the higher that cost. So at some point, there's a forcing function for you to collect or organize all the stuff that your particular team or organization cares about or owns, and put it all together so that you have the freedom to change it the way you want without having to go through cross-team or cross-org prioritization, approvals, all that stuff.
Awesome. Oh,
just
yes.
to give a case in point to support what you just said. So we were working with a client, I work for JW Player, we do with video, and we were speaking to the client, and they had a certain problem with like captions, and the solution was just to use VTT, and we asked them if they could do that, and they said, no, we don't own that. We have to do SRT because that's what they gave us. And that's, just thinking about the organizational structure, if they had, split their responsibilities differently, maybe they wouldn't be in such a bind.
Yeah, that's a great point. And thanks everyone for all of your correct answers. There's not one correct answer. I also heard someone when I was walking around say that the starting stage of the company matters a lot in terms of how you want to modularize the code base. So yeah, like basically these are just some examples. Really just, I don't need to read through them because you all shared these already. But I think the point is that it's why I find this work really interesting is that it's an interesting combination of software and people, whether the people are teams and how teams interface with one another, like this person mentioned just now, whether the people are developers trying to build their code faster and into smaller modules, and obviously users, right? Building a UI that feels really cohesive, that makes users feel like life is good. I just have a little bit of time left. I have no idea how long I've been talking, but I'm just going to talk quickly about some of the things I learned doing this at Twitter. So at Twitter, there was a iOS sort of developer-wide initiative around modularization that was led by the platform team. And then also product engineering teams, so teams that are really focused on specific features that they own, were also involved in this kind of work. So I was at Twitter, I worked on 2 product engineering teams. Like I mentioned, I started on the in-app purchase team and built a framework and package there. And then I moved to Spaces, observed very slow build times and all these ergonomic issues that I wanted to improve. So a quick version of what I did was there was a lot of code and a lot of complexity in one place. And so I ended up leading this project in 2 stages. The first stage was basically a Swift-only framework, and we had to use framework for certain things because not everything in the Twitter app was in a package. Yeah, so the first stage was building a framework and basically socializing this new framework to my team. Obviously, I got feedback on a technical design document, but I, shared with the engineers, use this if it's useful for you. So it wasn't obligatory. It wasn't like a major required change. And the thing that I did in that framework was build a sandbox app. So it's basically, imagine just like a app that just has features related to what we were building. So instead of launching the entire Twitter app and navigating into a specific feature, the whole app that we were developing was just Spaces features. And then we just kind of rocked with that infrastructure for 6 months or something. And then there was a second stage, which was more of like a big re-architecture and migration, where we tried to create additional modules for different kinds of Spaces code. So that's the fast version of what I did. So here's some things that I learned throughout that process. So first of all, I think it's really important that when you do this kind of work, you have a list of things you're not going to do. And the things that you are going to do should fall within some kind of prioritization framework. In this project, basically the emphasis was making architectural and infrastructure changes to unblock migrating code, but not necessarily migrating code ourselves. I would lead this project and I worked with 2 other engineers on it. But doing that was a conscious choice, and we thought that was a better use of focused work than just moving files over. And that felt like something that could be integrated more into the general process of doing our work. Second rule, always be useful. So I think this is really important. If you are making changes that are going to impact your team member's life, it's always useful to think, am I doing something that's immediately useful? Or am I just making someone's life more trickier, more complicated, making things take longer? Obviously, everyone does any code changes with positive intent, but in this project, I basically started with a sandbox, and I started with an environment that was extremely fast. And it wasn't obligatory, like I said, but the idea was, first of all, I wanted to work in a faster environment, but also I wanted my teammates to be able to do that. And so what ended up happening was that because I started really early and built this helpful tooling, people just started using it. And then by the time we had to migrate code, a lot of code was already there. This is related to this third point. I think time is useful in a couple of different ways. First of all, I think if you're making changes to how a code base is architected, time is a very valuable tool in sort of, let's say you have, what's like 2 engineers, 3 opinions. I don't know, there's some kind of joke there. But, it's very common that you will disagree and commit, right? You decide, okay, this is the path we're going to take. But when you sort of structure and sort of strategically plan the work so that changes don't happen too quickly and people have a chance to get to know the architecture that you're suggesting, I think it leads to a lot less conflict and a lot more bought-in team members. I know I've worked on apps before where somebody that I worked with was like, we have to do it this way. And then I'm just working with an architecture I didn't really understand. And then, it just made it more difficult for me to do my job. So that's something that I thought worked really well in this project. And then the other aspect of time is like, if you start doing something that would be valuable earlier, you kind of orient the code base in a good direction so that maybe 6 months later, you can pick up a project that is closer to where you want to be, and then maybe you can do a more active stage of making changes. Defining an ending goes back to when did this project end, and the question before. And it relates to prioritization. Like, you need to come up with an end to the project and probably several ends, right? Like several milestones that represent successful and helpful pieces of work, because finishing everything is not in a gigantic code base, that's probably not the right ending to be thinking about. This is related to the point before. Code bases are org charts. What I mean by this is that how you modularize your code is a good way. It can be used to sort of reflect who's responsible for this code, who owns it, and creating a very functional organization, a very functional tech organization, when it's very clear where the boundaries are between different features. And always involve as many people as possible, whether it's just input on a TDD, like a technical design document, or collaborating so that you have multiple advocates for something new that you're doing. I worked really closely with an amazing platform team engineer, and I really recommend modularization efforts that combine platform teams and product engineering teams, because you really need both to be bought in and really understand the architectural changes. In conclusion, I think this is a really interesting topic. This topic has everything. It has architecture. It has how do developers think? What do they want? What do your teammates want? Who are they as people? How can we make this environment better to work in? One thing that I think is really, really valuable about it in terms of personal and career growth is it helps you actually understand how maybe a feature or an entire code base fits together in a way that you don't really get to do hands-on, just building a specific, smaller, more isolated feature. So I think I personally felt like I grew a lot doing this kind of work. And make your developer friends happy, personal growth, learn more about the project you work on and iOS development in general. And like I said, modularization can also allow you to ship, maybe the first version of a project wasn't quite the right approach. And then, there's I don't know if people have, heard about ChatGPT or OpenAI launching ChatGPT in 2 weeks. So there's a whole story there, but sometimes you have a sense of urgency that something should be shipped. And the more modularized a code base is, the easier it is to really innovate and iterate faster. So yeah, here's my contact. You find me on Twitter or LinkedIn, email me, and then yeah, talk to me about cool companies you're at. Yeah. Oh, and let me know if you have any questions.
Any questions?
I was going to ask which of those slides do you think you could use for other talks, but
oh my God, that's such a good question. It took me a second. Definitely the hire me slide.
Any other questions or puns?
Hi, just wondering if you had any situations where you thought, oh, modularization is not the way to go here. It's better to keep things more monolithic.
Yeah, I think that's a really good question. I have two answers that come to mind. One is that I think the order of how you modularize a code base matters a lot. So you want to always be doing something that's helpful. And so let's say you start modularizing a code base in a way that people don't really buy and is a lot of effort, maybe requires a lot of changes. I think that you might lose steam and end up in some kind of in-between state. So I think that like what you're actually doing can make it either a good or a less good idea. So it's not a direct answer to your question, but it's more like how you do it matters a lot. And I mean, I would say, if you're building something completely new and you're under time pressure, you don't want to spend too much time doing things that are maybe going to be thrown away. So like maybe building a module for your networking layer in like a 5-person startup doesn't make sense, but there might be something there that you want to pull out. I mean, sometimes companies like AWS was an internal tool that then Amazon started to sell, right? So, sometimes you could be surprised by how modularizing something or having it standalone could be, a vehicle for a company's growth. So I would say don't over-engineer when you're thinking about this, but it definitely becomes very important in a big company.
Thank you.
Any more questions? Well, I can't emphasize enough to the sandbox point because you really need to be able to compile quickly, and that's like one of the main awesome benefits of modules for sure.